Okay, question 12 here. A copper tube here, 5 meters long, an outer diameter of 1,450 millimeters. Outer, notice it says, and with a wall thickness of 25 millimeters. It's filled with water at 1 bar. What's the maximum strain? So for this one, what can we say? So we know that we can basically, the length is irrelevant because we are going to be looking for the hoop stress, hoop maximum stress, maximum strain, both in the hoop direction. So the length isn't relevant. Watch out that we're dealing with outer. We want to look for a maximum strain, so we want to go to our formula booklet and find the right formula that we can use to find the maximum strain. Yeah, can you spot it? And hopefully you can spot it or look it up in your formula booklet and see if you can come up with one of these answers. So can you get one of these answers here? We're looking for maximum strain. Pause the video, and when you're ready, press play. So just going back to my formula booklet, I'm looking for a strain, I'm looking for hoop, so it's this formula here that I want to use. That's the one to use. So the strain in the hoop direction is PD 4TE to take away the Poisson's ratio. Right, so if we just go back, just check I've written that down correct. So PD divided by 4TE, open bracket, 2 take away Poisson's ratio, close bracket. So that's where I'm going to get the most strain in this pipe. And should just be plug in my numbers now. So 1 bar is 10 to the 5. Diameter will be this number, take away 2 thicknesses. So that becomes 1.4 in terms of SI units. 2 take away 0.3. And we've got a thickness of 25 times 10 to the minus 3. And we've got Young's modulus of 100 times 10 to the 9. Now, to avoid making an error on your calculator, good to write this number either as type it in as 100,000 or explicitly tell yourself to remind yourself to say 1 times 10 to the 5, because I did a mistake in the solutions. So it's if you just say 10 to the 5, it's easy then to type into your calculator 10 to the power 10 to the 5. So if we put the 1 there, we explicitly won't forget it to put it in. So 1 times 10 to the 5 times 1.4 times 2, take away 0.3, close the bracket. And that's divided by 4 times 25 times that to the minus 3 times by 100 to the power 9, close the bracket. So that gives me 2.38 times 10 to the minus 3. That's likely I'm going to want microstrain. So yeah, if I press my enter button, it gives me to the minus 6. So that's 23.8 times 10 to the minus 6, where that is a microstrain. So that's what we are looking for. So do we have any 23.8s? Yes, we do. That one there. Okay, so hopefully you chose A.